Hello everyone and welcome to another video in Walrus Code. Today we are going to learn about the basics of VPCs, private subnets, public subnets. How can we set up instances in public subnet and reach them over SSH, and also set up instances in private subnet and reach them over public subnet through a jump server. And also we are going to see if there is some time. If there is time left, we're going to set up a night gateway in order to provide internet to instances in private subnets. As you know, instances that are inside a private subnet are not accessible from the outside, from the internet, from the public internet, because they don't have a public IP address, but they do have access to the internet if we provide them a NAT gateway. But this access is just in one direction. They can reach outside, they can reach the internet, but it doesn't work in the other direction. We're gonna also set up root tables for both of the subnets, and also we are gonna set up an internet gateway, which is finally what enables us to map instances in public subnets to the internet and to enable. Basically, it's enabled the instances to be reachable by everyone. So this is a VPC. This is the basic architecture of a VPC. It can become much more complicated, but we are just learning the basics right now. First, it's very important to clarify that a region may have many VPCs that their relationship, but a VPC belongs to a region. You can connect VPCs between regions. I mean, you can connect this VPC to a VPC in another region that is called a VPC peering, but we are not gonna show that in this tutorial. And a VPC may have one or more availability zones. I mean, public and private subnets are attached to an availability zone. In this example, this is very simple. This example is not highly available. What does high availability mean? High availability means that your infrastructure resides in two or more availability zones. That means if one of those availability zones, is shut down because of a massive failure, for example, the rest of the infrastructure in the other availability zones, or ACs, are still operating because you had redundancy. This is not a redundant architecture, but that's okay. This is just a basic tutorial. But if you want high availability, strive to have at least two availability zones. All right, let's do this. So first, we need an AWS console, an account. You can do this everything in the free tier. I think you may be charged a little bit, a couple of cents, but if you recall to erase the VPCs. But I think you're charged for the operation of creating it, not for the, I don't know. I don't think you're charged for owning VPCs, but you're charged for owning a NAT gateway. That is expensive. You should erase it immediately after creation. And you are also charged for instances, unless you created instances in the free tier, which is basically the T2 micro. The T2 micro is in the free tier. All right, so let's go to the VPC console. I am already there, but you can reach the VPC console like this. And then you're here. First, every region, now I am in Ohio, which is US East 2. Every region has already created a VPC. This is the default VPC, and it owns only public subnets, but it is there, so that's why you can immediately launch instances in whatever region you want. That's because there's already a default VPC created for you. But we, in this tutorial, are gonna create a VPC on our own. And the first thing we have to understand when creating VPCs is what is the IPv4 CIDR. This looks pretty much like an IP, but what is this slash and then 16? So this is a notation very useful to define a block of IPs. This is a subset of IPs. And how many IPs does this block has? 16? No, actually much more. And there's a formula I'm gonna show you right now. This is the formula you use to create CIDRs, to define IP blocks IP. So whenever you use a number, so for example here /16, that means your prefix is 16 and you have a block of 2 to the power of 32 minus 16, which is 16 actually. So 2 to the power of 16, that means you have an address block of 65,000 IPs. That's the availability of IPs in this block. So the default the default VPC has a block of IPs of 65,000 IPs available to every instance that is created under this VPC. That's amazing, right? But what if you don't need such a huge block of IPs? What if you are already fine with a block of 256 IPs? That would mean 2 to the power of 8. So and a /24 block would be enough in some cases. And that is the example we are going to use now. So let's create our VPC and let's define our CIDR first. Does it make a difference if I choose another initial IP? This could be looked at. This could be looked as the base IP, the initial IP, the one which sets the offset of IPs. Actually, let's look at this tool. This is the CIDR calculator. It is online, free for everyone. You can put there a CIDR like this one, like the one. I'm gonna copy this and let's paste it here and look at this. So this is a very it's very useful, this calculator, because it tells you exactly which one is the first IP of this block and the last one. As you see, this is the last IP. So this is theoretically the 536 IP address. Yes, I'm struggling with the English numbers, but that's why I'm doing these videos in English. You know, I'm putting into practice the English language. I was used to speak in German for a whole and a half year, so now it's very good to train my English a little bit. Well, yes. So every time you want to calculate and corroborate that your CIDR IP block is fine, you can use this calculator and guess if you were right or not. So let's create our VPC first. Let's define our CIDR. And I think the first block can always start with 10.0.0.0. And as we know, we don't need a huge CIDR, so 24 is okay. That's gonna give us a total block of 256 IPs, as we see. And this is the last IP we can use in our VPC. Okay, yeah, I think that's gonna be enough for this example. And now let's write our CIDR. That's the tag. The CIDR is gonna be here. /24. So manual input, that's fine. What else do we need? I'm gonna name it like my first. I'm gonna move the microphone a little bit. My first VPC. So we are not using IPv6 for now. Maybe in another tutorial. Tenancy can be default, and that's it. That's everything you need to set your first VPC. Amazing, isn't it? And now, what else does a VPC has? I mean, look at this. We have a bunch of our much more elements than just a VPC. We have route tables, we have public subnet, private subnets. So let's create subnets first, because without the subnet, we cannot create instances or other elements like databases and stuff. So let's create a subnet. I'm gonna create a subnet, and there's a very important thing. We have to select to which VPC does our subnet belong. And now it belongs to my first VPC, the one we created recently, public subnet. I'm gonna name it the public subnet. Availability zone. Now I can choose an availability zone, and Ohio has 3 availability zones, so let's choose the A, availability zone A, and pay attention to this. Now I have to define another CIDR block, but this one has to be smaller than the general CIDR block of the VPC. Otherwise, there's not gonna be a space left to other subnets. Do you understand? So if the CIDR block of the whole VPC has space for 256 IPs, then each subnet must have a smaller IP block in order to allow the creation of other subnets. Although 256 IPs is not so much of a space, so I think every subnet is gonna have at most 64 IPs. So that means a CIDR block of 26. That's gonna be the CIDR I'm gonna choose now. /26. Okay, and if I put this in my calculator, that means the last IP is gonna be this one, which is fine. Okay, that's it. That is our private subnet. And now let's create immediately another subnet. That is the public one. Now I'm gonna create the private one. Let's create the public subnet. Let's create a private subnet, I mean. Okay, and let's choose the same availability zone. Why not? This is not highly available, but that's fine. This is only a tutorial. And so, may I choose this CIDR block for this private subnet? And the answer is no, because if I choose this one, this has the same range as the public subnet, so the two subnets would collide. They would have the same IP addresses, and that is not possible because we cannot overlap the IP addresses of two subnets on the same VPC. If they were different VPCs that are not connected with each other, then that would be fine. But if you have two block spaces, two CIDR blocks, I don't know, in the same VPC, then you don't want to have collision. So the first IP should be the continuation of this one. So what if I choose here 64? What if I write here 64? And that is what I need now. Now my first IP of the private subnet may be this one, and this one does not reside on the other subnet. So this is not this doesn't collide with the other IP block, and that's fine. That's what we need now. So I'm gonna put this CIDR here, and that is gonna, and now I have to put exactly the CIDR block. That's fine. So now I do have two subnets associated to this VPC, the public and the private subnet. But first, I'm gonna explain to you the private subnet. Both subnets are still private. The public subnet is also private because I haven't attached an internet gateway, and that is what changes everything. If I attach an internet gateway to the VPC, and if I configure a route table, then that is gonna make a subnet public. So let's create first an internet gateway. So I have to go here in the menu and create internet gateway, just as this, my first internet gateway, and now I create it. And then when it is created, I can attach this to a VPC here or here too. So let's select my first VPC and then let's attach. So just like that, it was very easy. Now my VPC has an internet gateway, but it is still not routing traffic to my public subnet because I haven't set up a table. So let's create a route table. So I'll go to route tables here in the menu, create route table, public route table. I'm gonna name it like this, and then the VPC, my first VPC. So I think this is, and now I can associate subnets explicitly to this route table, and that is what I'm gonna do now. So let's go to the public subnet and let's associate it to a public route. Can I do this? I think so. First, I'm gonna enable auto-assign IP, public IPv4, because otherwise I won't have automatically public instances. And I can use this to enable resource name DNS A record on launch. That's useful, I think. I think that's useful for us if you are using a VPC resource name DNS A record. I think that I'm not pretty sure. I can click the info maybe because I'm not sure. So that means if you query, do you know what is a DNS? There are a lot of kind of records. There are the A record, alias record, CNAME record, and each instance becomes a name whenever you launch it. I'm gonna show you later, but if I enable this, you can, yes, you can resolve the alias of or the name of this instance. But okay, let's check the ticket and save. But I'm still missing some configuration. The route table is this one. And that is the main route table, but I want to associate this subnet to another route table. That's the thing, and I don't know if I can change it. May I change the route table? Yes, edit route table association. So I don't want, look at this. This is gonna be important. Whenever you create a VPC, there is a default route table created, and I'm gonna show you right now. So if I go to route tables, I have not created this route table. I mean, I created the public route table, but I didn't create this one. And this one was created with the VPC, and it is a main route table. And this is the VPC I created already. So every VPC comes with its own route table, but I basically ignore it because I like to associate subnets explicitly to route tables I create myself. So like this one, I created the public route table, and now I can go to subnets, public subnet. You can ignore the other subnets, public A, B, C, because they are from the default VPC. Amazon creates these VPCs with your account automatically. You can ignore them, but you can always use them. So let's edit the route table association. As you know, subnets are by default associated with the default route table, and I want to use my route table. Save. And that's it. So now I can go to my public route table, and now I can finally do the association between my public subnet and the internet gateway through the route table I defined, and that is done here. So routes here, you're in your public route table and you see routes. What does it mean? Every IP in this block, I think my webcam is not allowing to show this, but okay. Every IP in this CIDR block means it's local, it's part of the VPC. But how can I tell anything that is not inside this CIDR block to go to the outside, to the internet? How can I do that? That is very easy. I can edit routes here, I can add route, and I can add this one, the 000/0 IP. What does this mean? This is the universe, the entire universe of IPs. I mean, any IP that is not here is gonna be in the rest of the universe, and that is this. And I can map this to the internet because basically the internet is the rest of IPs I want to map in a public subnet, right? So internet gateway, I can choose the internet gateway I created, and now I save changes. And that's fine, that's ready. Now we have a public subnet which automatically associates an IPv4 to an instance. And we can put it into practice right now. Let's do this. Let's launch an instance. And so let's go to EC2 then. Let's go to EC2. I'm gonna launch an instance. That's gonna be very easy. Launch instance. So a quick start. Let's use an Amazon Linux. Yes, an architecture x86. I mean free tier, the T2 micro. Let's use a keeper. This is my keeper. I think I'm gonna create a new one, I guess. Which one? I don't recall having any of these ones, so I think I'm gonna create a new keeper. So just a key. Yeah, just append and RSA, that's gonna be enough. And now it downloads. You have to download this key. And network settings, let's edit the network setting and take a look at this. By default, there's the default VPC selected, but now I can choose another one, and that is the one I'm gonna choose, the one I created recently. And take a look, now we can choose either the private subnet or the public subnet. I'm gonna choose the public one because otherwise our instance is not gonna be reachable from the internet. And I'm gonna SSH to it through my terminal. So I need the internet in this case. There are workarounds to that. I could use a VPN site to site, but that is something I could explain in another tutorial too. For now, let's use the internet and SSH and security groups, of course. So maybe I can select an already existing security group. No, let's create a security group, launch Wizard 5. It is gonna allow SSH from anywhere. Maybe that is not that secure, but for the purposes of this tutorial, it's gonna be enough. But you always want to put here maybe the IP of this machine you are connecting from to reduce the scopes of attack. So that is a way to protect. Or even better, you could block any access from the outside, even SSH. Because you can use also the SSM agent, the systems, how do you call it? The system managers. But yes, this SSM agent, I can talk about that in another tutorial too. Okay, so the default root volume, GB2, it's gonna be fine. And yep, that's it. Let's do this. Okay, meanwhile it launches, I'm gonna create the private route table. Let's create the private route table. Route tables, create another one. Private RT. It's gonna be in this VPC, yes. And now let's associate the private subnet, I mean, to the private route table. Edit route table association. Private route table, save. Okay, that's pretty much it. What else? Okay, so I'm gonna show you, in order to finish this tutorial, I don't want to extend it too much. I'm gonna show you how to launch an instance in a private subnet, and we are gonna corroborate that it is not reachable from the outside, but if we SSH to the public instance, then we will be able to ping this instance, because instances on the same VPC can ping each other if the security group allows that. And of course, I'm gonna put a security group in this instance that allows pings or connections from this instance. So let's do that right now. So VPC, okay, let's launch another instance now in the private subnet, but the steps are very similar. I can name this private instance. So the same Amazon Linux 2 operating system, this is gonna be enough. Let's use just a key, the same SSH. Although I think I'm not gonna SSH to this instance from the other instance, I'm just gonna ping. So create a security group. But first I have to choose another VPC. Don't forget about that. And now I'm gonna use a private subnet. So I don't remember if I allowed public IP. I think I allowed it in the other one, but okay, let's remove this one and let's add another. Do you know which is the protocol for pings? It's this one, I think. ICMP, I think this one is for ping. So I'm gonna allow that in all port ranges, source type, anywhere. Or custom, maybe from security group. Yep. Launch wizard 5. I think I can allow this. I'm gonna do it from anywhere, but because I'm not sure what was the name of the other security group, but you could do it much more secure if you allow pings only from the instance that is in the same VPC. But okay, this is gonna be enough for this demo. And let's launch the instance. Okay, let's go to the instances, and I think I should have here 2 instances, and the instance in the public subnet is already running. So let's check what is the public IP. Is this one? So I could just SSH to it. So I have my key here in the terminal. I'm already ready for connecting, but you know, just for in order to show you, in these instances console, you can use connect, and there are 4 ways of connecting to the instance, and now I'm gonna use the SSH client. And what is cool about this is that you have the whole command already written here. You can just copy paste it. So I go to my terminal. Of course, you have to make sure the key is in your path, but the key is already in my path. I checked it, and I can paste this command here, I think no. Okay, let's copy it again. I think it didn't copy. Okay, let's connect actually. Now I write yes. Okay, this is a very common error. I'm gonna fix it right now, but if you didn't know, keys must have a special configuration of permissions if you're using Linux. So I'm gonna use sudo chmod 400 I mean, and then just a key. That means I'm setting the root permissions on this key. That is the safest one. I'll write my password here, and that's it. And now it should work. It should work. Okay, yes, I'm inside the instance. How do I know it? Because now the prompt changes. Now it says EC2 user, and this is the IP. Actually, this is the private IP of the instance, but I am on a public instance. I connected to this instance in a public subnet created by us. Look at this, it's amazing, right? And now, in order to conclude the demo, what should happen? Okay, let's go to the instances first, and what should happen if I ping this instance, the private instance? First, I'm gonna try to first, let's check, let's corroborate, let's confirm that it doesn't have a public IP address, because it is not in a public subnet. So you cannot reach this instance from anywhere. It is only reachable from inside the VPC. And how can we get inside the VPC? You need a bastion host or a public instance that is accessible from the world. Basically an instance in a public subnet. And I am already inside of this. So from this, I can ping instances in private subnets, and let's try that. So we don't have a public IP, I mean, but we do have a private IP, and that is reachable from inside the VPC. I have repeated that tons of times, but that is basically what I wanted to show you in this video. So ping that, and it's working, guys. I am reaching an instance in a private IP from an instance in a public IP. That is basically what a jump server does, what a Bastion host does. That is the idea. And that is a more secure way of accessing stuff in private subnets, because this instance is protected from the outside. It is only accessible from here. If you have to use tight security group. The security group I attached here is not so tight as it should. I explained to you. It should be only allowing access from this instance, but you can change that. And yes, I think I could talk hours about this, but that's enough. I think you learned how to configure route tables. I think the NATO gateway can be a part of another video, because there's so much to explain about everything. But yes, so if you like this kind of content, don't forget to smash the like button and subscribe if you're new to this channel, because I upload content like this every week, or at least I try to do that.